everyone, we're going to do some calculations on diprotic weak acids, and the diprotic weak acid we'll work with is carbonic acid. If you think about it, carbonate, CO3-2, can exist in three different forms. There's the unprotonated form in sodium carbonate, or A-2. There's the intermediate form, sodium bicarbonate, or HA-, also found in baking soda. And then there's the fully protonated form, carbonic acid, H2CO3 or H2A, but I can't go to the stockroom and get a bottle of carbonic acid because anytime carbonic acid forms, it rapidly decomposes into CO2 and water. So the best thing I could think of to do was to get this bottle of mineral water. That'll be our carbonic acid. It's got dissolved CO2. So I'm going to prepare solutions from all three of the solutes I just showed you, and then we'll talk about how to find the pH, because the approach that we take to find the pHs of all of these solutions depends on the form that was used to prepare the solution. So let me begin with carbonic acid, since the solution has already been prepared for me. I went to the store and bought it. And now I'll prepare a solution of sodium bicarbonate. And I'm not being very careful. I don't really know how much I'm adding. And let me dissolve that salt in water. And finally, I'll prepare a solution containing A-2, again using this sodium carbonate. Again, not being very careful with how much I add, pretending I'm an organic chemist again. And let me dissolve it in a little bit of water. So when calculating the pHs of these solutions prepared from either A-2, HA-, or H2A, the approach that we take depends on which form was used to prepare the solution. Now, let me ask you this. If you have a solution prepared from the fully protonated form, wouldn't you expect the pH to be acidic? Let me add some universal indicator to all three of these solutions. And as I do that, you'd be thinking about what you would expect the pHs of these solutions to be. So, fully protonated, that looks acidic. Intermediate, okay, that could be somewhere intermediate. And now unprotonated, that's basic. Let me give these a stir. Fully protonated, intermediate, and now unprotonated. So once we start doing our calculations, we should get acidic pHs for the fully protonated form, intermediate pHs for the intermediate form, and basic pHs for the unprotonated form. Now you saw me prepare this solution by adding sodium carbonate. Would you believe that there is a little bit of bicarbonate and a little bit of carbonic acid in this solution? There is, because of the Kb reactions in which carbonate participates. And you saw me dissolve the CO2 into this beaker. But would you also believe that there's a little bit of bicarbonate and a little bit of carbonate in this solution? We're also going to calculate the concentrations of those solutes in all three of these solutions. Again, the approach that we take depends on which solute was used to prepare the solution. Was it H2A? Was it HA minus? Or was it A minus 2? So get ready for some quick and dirty calculations and maybe even a systematic treatment of equilibrium. Hope you enjoy these calculations and thanks for listening.